let's go over the normal distribution worksheet. So a company makes containers of milk. The volume of milk in the containers is normally distributed with the mean of 260 milliliters and a standard deviation of 6. A container which contains more than 271 milliliters of milk is overfilled. So a couple things about normal distribution. The one key here is they have to tell you. They tell you when it's normal. It's in normal distribution. Unlike binomial, where they don't tell you, kind of got to infer from them saying exactly, at most, at least, there's only being two options. Normal, they should have to tell you, hey, this thing falls in normal distribution. So if you see that, that's when you know it's normal. It's no secret. They're like, hey, this is normal distribution. You're like, okay, I should do my normal distribution stuff. So, now what do they give you? So in this case, they give you mean and standard deviation. All our worksheets say is going to be giving you that stuff. Eventually, we won't. But for now, you just use that. So the mean, which is this symbol, and the standard deviation, which is this symbol, is given to us. The container is chosen at random. Find the probability that is overfilled. So we want to find the probability it's more than 271. So I like to draw it. So my mean here is 260. 271 would be to the right of that somewhere. Doesn't really matter where. And then we want overfilled. So we want to the right of that. Well, it actually isn't overfilled. It's more that wants more than. That's why I filled this side out, because it said more than. Overfilled is just what we're labeling it. The fact that it said more than means on this side. But in general, overfilled would be to the right or greater than to the right. Underfilled, stuff to the left, shorter, left. So you want to figure out what that is. Now, what we're going to do is use our calculator for that. We got to know what to type in. So we're going to use normal CDF. And they're going to want four things. They always ask for the lower bound, the upper bound, the mean, and the standard deviation. I probably should put mean with the symbol also. Like that. Now the lower bound in this case, you can see right here, clearly it's 271. The upper bound, it goes on forever. So in this case, it's technically infinity, but you can't put that into your calculator. So what we do instead is to use E99. That's our version of infinity. It's just a huge number. That's what that stands for. So I'm going to put E99. Our mean they gave it to us is 260. And our standard deviation they gave it to us is 6. I'm going to put that all into our calculator. So we're going to go to second distribution. Now we have two normals here. We have normal PDF, which we never use in this class. Never. And we have normal CDF. Next, on the next video, the next lesson, we'll talk about normal invert normal when we use that. But for now, we're only going to use normal CDF. So my lower bound is 271. You can see they already had the E99 there. And then we have E99. Now here's the thing about E99. It's not E. It's not 271. It's like chemistry. It's this guy right here. So second E99. You can tell the E is like an actual E, not cursive. And then my mean is 260. My standard deviation is 6. Hit paste, hit enter, and we get about 0.33. Now remember, we're IB, so 3 sig figs, so 0.033. Just like that. And actually, I think I'm missing a sig fig, so 34. 0.0334. The 0 right there doesn't count. So 334. That's because I rounded 7 with the 3 to get 4. So there we go. It's about 3% chance of something being overfilled. Find probability the container is not overfilled. So we want to know what this is, the non-overfilled value. So there's two ways to do this, right? Way one is do normal CDF again. We'll just do this side. It'll be normal CDF. My lower bound, if we're doing this side, would be negative E99 all the way to 271. Like my picture will be like this. Right, so it'll be negative E99. It's about 271. Everything else stays the same. So you can do it that way. Or we know what overfilled is now. Overfilled is this. So what's not overfilled? Not that. Anytime you see not, it's always just to do 1 minus the thing. So I'm going to do 1 minus that. So I'm going to do 1 minus my answer from above. So 1 minus, just click my answer. I get that 3 sig figs, 9.667. So I could wrote this part down. And my answer is 0.967. Right? So again, anytime you see not, if you know what this is, just do 1 minus that. Easiest way of doing it. A container passed inspection if its volume of milk is between 250 and 273 milliliters. Find probably that round shows volume passes inspection. So again, I'd like to draw it. So my mean right here is 260. Means always in the middle. So 250 would be below that by like 10. 273. Now notice that's a little bit further than this is 250. So if I did an equal value on this side, that'd be 270. But I gotta go 273. So you don't want it to be even. You want it to be a little off. Right? They do that. They would mark you down if it was like 250 and 280 is probably a better example. If you made it symmetrical, it would not be a good answer. Since this is only 10 away and this is 13 away, this should be a little bit further. They do check. And I want to pass inspection on between these two poles. So I'm going to fill my picture like that. And then all we do is normal CDF. My lower bound would be 250. My upper bound would be 273. My mean is 260, which I told us earlier. And my standard deviation is 6. Let me just put that into our calculator. Normal CDF, 250, 273. And it's going to get 0.937. So 0.937. Select something like that. Given that a container is overfilled, find probably that it passes its inspection. So you catch that? Given that. Man, IB loves that given that. So it's a given that problem. Remember the given that problem? The formula is probability A given B. I'm going to use the new formula they use now. The probability of A intersection B over probability of B. So that's straight from the formula book, formula sheet. And then we're going to type stuff in. So they want to know probability given that container is overfilled. So this is overfilled. Find probably that it passes inspection. So passes inspection. I'll put a PI. So something like that. Given that containers are overfilled, find probability it passes inspection. So pass inspection given overfilled. So you get this formula right here. So overfilled, classic IB. We figured out overfilled earlier, right? Overfilled is our first question. Find probability is overfilled. So 0.0334. So that's gonna be overfilled. And like I always say, the hardest part of this is the intersection. So to help me with this, I always draw like a number line. So passive inspection, we did it right here. Passive inspection between 250 and 273. So if I draw like a little number line here. Here's 250. Here's 273. So passive inspection is between these two. Now, overfilled. What's overfilled? Overfilled is more than 271. So there's 273, so 271 would be like over here somewhere. So something like that. That's overfilled, right? So overfilled is this line. Passive inspection is this line. I want the intersection. So that's where they overlap. So that turns out to be between 271 and 273. That's what that is. So this is between 271 and 273. So how do we find that? Just like we found this one right here. Like if I was going to draw that picture, if I was going to find the probability that you're between 271 and 273, it's just like doing this guy, but just between 271 and 273. So like on my normal curve, that's an embarrassing normal curve. I want to erase it. All I did was highlight it. Something like that. I'm going to have 271 and 273. I'm going to find it in between. So I'm going to go normal CDF. Lower bound 271, upper bound 273, mean of 260, and standard deviation of 6. So my calculator, let's do that. So second distribution, normal CDF. So lower bound is 271, upper bound 273. Everything else stays the same. I get 0.018246. So 0.018246 546 over 0.0334. Then plug that into my calculator. Again, notice how I didn't go 3 sig figs here, because I got that answer in the part of this problem, so you don't want to round it if you're inside the problem itself. But since I got this answer from before, I could use the rounded version, and it's okay. So it's a distinction that IB makes. And within the problem, they don't want you to round until you get the answer. But if you're using an answer from previous that you did round, that's okay. So then I'm going to divide by 0.0334. And I get this, and then again, here's my answer. So 3 sig figs, so 546. 0.546. And you get that. So that's the odds if it given that container is overfilled, find the probability that it passes inspection. So if it's overfilled, there's a 50% chance it passes inspection. A sample of 50 containers is shown around. Find the probability that 48 or more containers pass inspection. So look at this problem. Notice that they broke it down to a sample of 15 containers. So already your spider starts to be tingling. Something's going up here, right? Find the probability that 48 or more. This is a binomial distribution problem. Right? Because you could either pass inspection or not pass inspection. There's a sample, you could pass inspection or not. This is a binomial problem. They just snuck it into here. IB loves to do this. They love to add a binomial problem. To anything really, to any probability, any type of stats problem. They'll add a binomial problem at the very end. So in here, this will be my n, right? Binomial problem need n, p, and r. My n is number of samples, trials, so 50. Probability. The question is passes inspection. Then we find that passive inspection is over here. The odds of passive inspection is 0.937. So that's my probability. Odds of passive inspection. And then with my R, I want more than 48 or more. So 48 or more means X wants to be greater than or equal to 48. Right? It's 48 or more. Now again, remember binomial, it cannot be pointed greater than, it has to be less than. So I got to fix that, point in the wrong direction. How do you fix point in the wrong direction? You do 1 minus it. When you flip it though, it had the sign, now it loses it. That's not good either though, right? Because now I'm less than 48. You have to be less than or equal to, so you have to go down 1. So my R is going to be 47. I'm going to type this into my calculator. I'm going to do 1 minus binomial CDF of X is less than or equal to 47. So let's put that into our calculator. 1 minus, I always like to do that first so I don't forget. Distribution, now we're going binomial toward the bottom. CDF, trials is 50. Probability is 0.937. And the value is 47. Hit enter, and I get, again, 3 sig figs, 0.382. About 38% chance to have 48 or more pass inspection. So there we go. Let's move on. Random sample is distributed normally with a mean of 70 and a standard deviation of 4. So again, notice how they tell you it's a normal distribution problem. So we know it's normal. They give us the mean, and they give us the standard deviation. So they want us to find between 70 and 74. So I always like to draw the picture. My mean is 70, so right there. 70 and 74, so 74 is over here somewhere. And up is between those two. So we normal CDF, 70 lower bound, 74 upper bound. Mean is 70, and standard deviation is 4. Put that into the calculator. So 70, oops, I put binomial, so we're going to quit, get out, because I messed up, and go to distribution, and go normal CDF. So my lower bound is 70, upper bound is 74, mean is 70, and standard deviation is 4. Again, 3 sig figs, 3.41, 0.341. Next one, same idea, just now you're between 68 and 72. So 70 is my mean, 68 will be on the left side of it. 72 will be the same distance away on the right side, so I want to make it as similar as possible, as symmetrical as possible. But they're both 2 away, so you want that to be symmetrical. So there's my lower bound, there's my upper bound, and plug it into the equation. The exact same thing. Almost went down to binomial again. So now it's gonna be 68 to 72. Everything else stays the same. 0.383. The one over here. Now it's less than 65. So again, I like to draw it. Here is 70. 65 is to the left of it. And you want less than 65, so that's all this. Now, in this case, right, our lower bounds be negative infinity or negative E99, since we don't have an infinity button. And then upper bound would be 65. So we normal CDF, negative E99, 65, 70, and 4. So we're going to type that in. So second distribution, CDF. Now, very important, a lot of people put subtraction sign. That's a subtraction sign. We want a negative E99, so we use a negative sign. Subtraction will get you error. Then we want E. Remember, it's not E like that, like a log. It's E over here. Then 99, and then 65. Everything else is the same. So 0.106. Like that. X is a round variable that's distributed normally with a mean of 60 and a standard deviation of 5. Find. So it's the same thing now. Our mean is 60 and our standard deviation is 5. So they want us to find these guys. So it's the same idea. Between mean is 60, standard deviation is 5, 65. So like that. Now that's a normal one actually. If you're just a standard deviation away, you should get about 34.5, I want to say. 34.1. So then we'll plug it in. But anytime you're one standard deviation away, it's always the same amount. Always. It's like 34.1, I believe. So 60, 65, 60, and 5. 34.1. 0.341. It has to do with the normal curve, right? It always has the same standard deviation. It's always the same. 34.1, I think 0.13.5, 0.02, yada yada. Same problem, but now between 62 and 67. So 60. Well, my mean is 60, so I don't want to draw this wrong. I was about to draw it wrong. So there's 60. So 62 over here, 67 over here. So that's my lower bound and my upper bound. So normal CDF, 62 and 67. So 0.919. Greater than 64. So again, I always like to draw it. Here's 60. 64 over here somewhere. Greater than be all this side. So 64 to E99. So second distribution, normal CDF, 64, E99. So 0.212. This one right here, probably x is less than or equal to 80. 68, I don't know where 80 came from. I'll draw it as always. 60, 68 over here. Less than or equal to, so all of this. Right? So all of that. So we're going to go second distribution, normal CDF, negative E99, because we're on the left side, so remember negative, then E99. Then we're going to 68. The rest of it stays the same, 0.945. Look at an application problem. A machine produces metal bolts. The length of these bolts have a normal distribution. Again, notice how they tell you it's a normal distribution with a mean of 9.8 and a standard deviation of 0.3. If a bolt is selected at random from the machine, find out that it will have a length between 9.17, 9.7, and 20 centimeters. So this is actually, I mean, it's an application problem, but it's a pretty standard normal problem. Here's my normal curve. The mean is 19.8. Right standard deviation is 0.3. We want it between the lengths 19.7 and 20. So 19. So another one where you don't want to make sure you're not symmetrical. So this is 19.7. And 20 should be like 2 away. So this should be a little bit further. Right? So, I mean, they're very close, but you don't want them to be symmetrical. So something like that. And that we just plug in our calculator. If you understand the gist of it, it's pretty simple, right? So we're gonna go second distribution, normal CDF, 19.7, 20 is my upper bound. My mean is 19.8. In my head, I thought they were like 19.7, 20 were further away, and I was like, no, they're just pretty close. Then my mean is 0.3. Hit enter, and you get 0.387. 0.378. I always mix them up. 0.378. There we go. Next ones. Max's customers put money for charity into a collection box on the front counter of a shop. The average weekly collection is approximately normal distribution with the mean of 40. So again, there's my mean. Notice again, notice the normal distribution and standard deviation of $6. What portion of the weeks would you expect to collect between $30 and $50? So again, pretty standard problem. The mean is 40. We go 30 and we go 50. So this one you want it to be as like it's not gonna be perfect, but you want it to be pretty symmetrical. So 30 and 50. Type it in. So second standard bars, distribution, normal CDF, always go there. And we're gonna go 30, upper bound would be 50, mean would be 40, and standard deviation is 6. Oops, I messed this all up. 30, 50, mean is 40, and standard deviation is 6. So 0.904. At least $50, right? So again, talk about what do we mean by at least? At least $50 means like at least 5 cookies. So 50 or above, right? So that's my lower bound. At least is your lower bound. So draw a picture. Here's 40. 50 will be over here somewhere. It's gonna be all of this. Something like that. So put in our calculator. Where am I at? Second distribution, normal CDF. We're going 50, E99. All the rest is there, and I get 0.048. So about 5% chance that you collect at least $50. Fields are washed onto a beach after a storm. The length has a normal distribution of 41 and a variance of 11 centimeters squared. So that's a little trick there. Mean is 41, variance is 11 centimeters squared. They give us a variance. They didn't give us the standard deviation. So remember, how do you go from variance to standard deviation? Variance is bigger. So we want to take the square root of that to get the standard deviation. Right, so variance is bigger, so it's always square root probability. Variance is a bigger one, so you square root to get the standard deviation. So my standard deviation should be radical 11. If a needle is selected, find the probability that it is at least 50 centimeters long. So again, another at least 50. It's actually at least 50 again. So there we go. You should know that, right? 50 is the lower bound, at least 50 cookies. So let's draw it out. The mean is 41. 50 is over here. And I want at least, so everything more than that. So my lower bound would be 50. My upper bound would be E99. Plug it in. Second distribution, normal CDF. Lower bound is 50. Hey, how nice, E99. My mean is 41 this time. My standard deviation is radical 11, so we just type that in. Square root 11. Paste, and I get 0.003. Or 3 sig figs, those zeros don't count, so 333. Find the proportion of yields measured between 40 and 50 centimeters long. So same type of idea. Here's 41. 50 is a little closer to here's 50. Here's 40. I'll say 50 is a little closer to 41. 40 is a little closer to 41. So notice how it's not symmetrical. So between those, so you want to make sure you're not symmetrical. You're asymmetrical right there. And then lower bound's gonna be 40. Upper bound's gonna be 50. So second distribution normal. So 40, 50. And I get 0.615. How many EOs from a sample of 200 would you expect to measure at least 45 centimeters in length? So this is an expected value thing, right? What do you expect to measure? If you remember expected value, it's n times p. Well, what's my n? Well, 200. What's my p? The probability that at least 45 centimeters in length. And we have not found that yet. Oh, come on, IB. This is normally a classic IB problem. So first we got to find this. X is greater than or equal to 45. So if we draw it out, here's 41, here's 45. So it's 45 to E99. I'm very disappointed in IB. That should have been a classic IB problem. It should have been greater than at least 50. Should have been. So we got to find this first. It's a normal CDF. If we're going 45 to E99, everything else stays the same. There's E, so it took me a second. 99, blah, 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 blah. I get 0.114-ish, so to put that in here. Now again, this is still part of the problem, so technically I should use my answer, not should use the round version. So I should use this and times it by 200. Because I haven't got an answer yet. And I got 22.8. So about how many eels? I mean, I guess you could say about 23 eels you'd expect. So there we go. Question 8. People found to have high blood pressure are started on a course of tablets and have their blood pressure checked at the end of 4 weeks. The drop in blood pressure over the period is normally distributed to a mean of 5.9 units and standard deviation of 1.9. So again, this normal says is normal distribution and a mean of 5.9 and standard deviation of that. So they give you all the information. You know it's a normal problem. They give you the mean. They give you the standard deviation. A final proportion of people who saw a drop of more than 4 units. So a mean is 5.9. I want more than 4. So 4 is on this side and more than. So like that. So we're going to go normal CDF. Lower bound to be 4. Upper bound to be E99. My standard deviation would be 5. My mean would be 5.9. My standard deviation would be 1.9. You just plug that into our calculator. So second distribution. Normal CDF. 4. E99 could stay. 5.9 and 1.9. 0.841. So there we go. B, 8 people from a large population taking the course of tablets are selected at random. Find the probability that more than 5 of them will show a drop in blood pressure of more than 4 units. So this, notice that again, they're selecting 8 people from this population. This is another sneaky binomial question. They're trying to sneak it in there, right? So they're selecting 8 people out of this big old group. Find probably that more than 5, more than less than exactly. So a drop of blood pressure more than 4 units. So we're trying to either drop more than 4 or not drop more than 4. We just figured out more than 4 units. So when you do binomial, remember you need NPR. We just got P, 0.841. We have our N. They selected 8 people. I could read. So we just gotta find R. And what do they want? They want more than. That's the wrong thing. I'm probably that more than 5. I'm gonna put more than 4. So they want more than 5. Now, very important. More than 5. It didn't say equal to. It didn't say at least 5. It didn't say greater or equal to 5. It said more than 5. That's this guy. It's pointing the right direction. It's pointing the wrong direction, but it doesn't have a line. So watch this one. So it's pointing the wrong direction, so we have to fix that. So we do 1 minus. Right? Now, remember when you flip it, normally you take away the line. This one doesn't have a line, so you gain it. So you get that. Right? More than 5 is this. What's the opposite of that? Close circle this way. So that's where this comes in. And that's the proper way. I don't got to do anything else. I don't got to go lower down. That's correct. All I got to type in is 1 minus binomial CDF of x is less than 5. So put that in our calculator. I'm going to do 1 minus binomial CDF. Trials, we have 8 trials. Our probability is 0.841. And our x value is 5. Type it in, I get 0.879. I move my calculator away so you can actually see that. And there we go. That's the idea. So again, they always like to add if you see like a separate portion, always be wary, especially if they specify number of people. It's generally a binomial question. They'd like to add it into lots of stats questions, so just make it binomial out of nowhere. Next problem. The weights of cat at a local animal shelter are normally treated with an average weight of 10 pounds and standard deviation of 0.8 pounds. 0.8 pounds. Cats that weigh less than 8.6 pounds are considered underweight. The cat that shows a random find probably that is underweight. So again, let's draw it. So we have our mean. We have our standard deviation. So our mean is 10. We want underweight, so it's less than 8.6. So 8.6 be on this side, and less than that. So let's set up something like that. So how do we find that, right? Normal CDF. Lower bound is should be negative E99 because we're doing the left edge. Upper bound is 8.6. My mean is 10, and my standard deviation is 0.8. So let's type that in. So second distribution, normal CDF. Remember negative, oh, there we have it for us. There we go, done. 8.6. 8.6. Mean is 10, standard deviation is 0.8. Hit answer and I get 0.4000. So 0.0400. 36 figs. It's actually 0.1. I can't do my sig. I can't round. Right, so point that zero doesn't count. 401 to the curve. So right there. From the probability that cat is not underweight. So we talked about this before the beginning, right? Not just means 1 minus underweight. We already figured out what that is. If I do that, we're gonna get 1 minus this guy. Now I could just use this because that's gonna be the same answer though. So 9.60. Maybe it won't be, but you get about that. A cat is considered healthy when it weighs between 9 and 11 pounds. Find probably that around chosen cat is healthy. So the mean is 10. You got 9 over here. We got 11. We want this to be as symmetrical as possible. Something like that. So there's my lower bound. There's my upper bound. So normal CDF, 9, 11, upper bound, mean, and then standard deviation. So let's plug that in. So normal CDF, 9, 11, everything else stays the same. 0.789, 36 figs. So like that. Given that a cat is not, given that the container is not underweight, container, I'm probably it's healthy. I think they mean a cat. I think that's a typo. Cat. There we go. Given that a cat is not underweight, find the probability that it is healthy. So it's considered healthy when it's between 9 and 11. So again, let's just write out. Given that, right? So given that it is not underweight. So under but not, the little prime for not underweight. Find the probability it's healthy. So again, probability it's healthy given that you know it's not underweight. So we'll use the formula. Now again, the formula from the formula sheet is this. A given B. A intersection B over probability of B. So over here that'll translate to probability of healthy and not underweight over probability of not underweight. Now we actually know, again, classic IB, we know not underweight. We did this already. Not underweight is 0.96. Now it's always, like I said, this is always the hardest part. What is healthy and not underweight? So, where's my number line? I'll draw it right here. Healthy is between 9 and 11. What is underweight? Underweight's less than 8.6. So that's 8.6. Underweight is this way. So what's not underweight? The opposite way. So what do those things have in common? Well, remember, what they have in common is the overlap. And the overlap here is just this part. Not between 9 and 11. So this is a true classic IB question where both my values I have already. So the intersection of healthy and non-underweight is just healthy. So healthy is going to be 0.789. We just figured it out. So we already have both answers. We just type that in, plug into our calculator, and get our answer. 0.789. Since I'm using both answers from before, I'm going to use the rounded versions. Divided by 0.96 still works. And I get 0.822. So like that, that's a true classic IB question. Right, now again, this part's always tricky. Healthy and underweight, not underweight. So healthy is between 9 and 11. Underweight was less than 8.6, so not underweight, anything above 8.6. Where do they overlap? At the healthy at between 9 and 11. Okay, last problem. A random sample of 50 cats is chosen. Already. Dead giveaway, right? The random sample of 15 cats. This is the binomial question. If you're not sure, look at the next question. Find probably exactly 8 of them are healthy. Find probably at least 5 of them are healthy. They're adding up a binomial question at the very end of it. So this is a binomial question. We're going to need NPR. Now N is 15. That's the number of trials. P, what are they asking about? Healthy. So what is healthy? It's up here. They're healthy 78.9% of the time. So 0.789. Now R depends on the question, right? This one's exactly 8. So this is a binomial PDF where X equals 8. So we're going to have N15, P be 0.789, and then R is going to be 8 because it says exactly 8 are healthy. So go to our calculator. Second distribution. Got to go to binomial now. PDF still wants it exactly. So we have 15 trials. It's 0.987. What is it? 0.789. Man, I swear I'm not dyslexic. Maybe. And then 8. There's nothing wrong with that anyway. And you get 0.018. And actually, again, the 0 doesn't really count. So what is it? 0.01178. That's why I did the 8. There we go. The next one says what prime at least 5. So again, how do you do at least 5? That's X is I want at least 5 cookies. So 5 is my lower bound. 5 or more. That's pointing the wrong direction. So I got to flip it anytime it's pointing the wrong direction. Right? You got to flip it. So do 1 minus. Now in this case, unlike the last time we did this, when I flip it, I lose a line. So I just get this. I can't have a less than sign. You got to have a less than equal to sign. So you got to go down 1. So my calculator, I'm going to put 1 minus binomial CDF of X is equal to 5. Or less than equal to 5. 4. We just did it. It's 4. Sorry about that. Going to my calculator, I'm going to type this in. So we need 1 minus. Again, I always like to put it in because that way I don't forget. Binomial CDF this time. 15 trials, probably 789. I always forget, I double check. 789. 0.789 to be exact. And then 4. Hit enter, and we get 0.99999. So about 100% chance. So, boom. I should say 1.00, right? 3 sig figs, you move it all over. 1.00 because it's just in a round. So, there we go. That's it.